Alright, so let's start talking about the if and else statement in Golang. So what is an if and else statement? An if and else statement is used to run code conditionally. Now, that probably sounds confusing if you've never seen or heard about it before, so I think the best thing to do is to actually start coding. So let's actually create an if and else statement. So to actually create one, let's just start with if. We start with the keyword if, which is if, and like I said, it is to run code conditionally. Now, how do we run this code conditionally? It has to be either true or false, right? So if it's true, then we know, or by opening up some curly braces, Golang knows that it has to run whatever is within these curly braces. Whatever code that you put within these curly braces, if this statement is true, it doesn't necessarily have to be like exactly true. We can use conditional operators. We can do comparison, which we'll do in a couple of seconds. But if this statement is true, between this if and this curly braces, it's going to execute the code that you put between these two curly braces. So let me just prove that really quick. Let's do a little print, and I am going to open this up and put I am true. Right? Let me just run this, and boom, it prints out I am true because of the fact that if it is true, it is going to execute whatever is between these curly braces. Now, if it is false, right, and let me clear this out, and I run it again, it is not going to execute because it's false. If it's false, then it is not going to execute. Only if it is true, it is going to execute, right? But now we have a fallback, right? If it is false, right, and we can't execute this true portion, we can use a fallback such as else to run another separate case of code if this criteria is not passed. So if this criteria is not passed, else we'll run this code. So we know that it was false. So let's do another prompt. I am false. And let's run that again. Boom. It's going to print out I am false because this is automatically set to false, so it would never run this. But it has a fallback of else because, else is going to run this because the above code is false. Now, we learned so many things throughout this Golang tutorial series. We learned about arithmetic operators. We learned about conditional operators. Let's start using some of these things as we have learned in this tutorial series to actually structure a very complex, it doesn't have to be complex, but a more complex if and else statement, right? Because this is going to be used a lot when you start building upon your applications that you're going to do in the future. So yeah, let's get started. So we're going to create two variables, right? We're going to say value 1, and we're going to make that equal to, let's say 10, and value 2 is equal to, let's say 20. Actually, no. Let's create a structure. We just talked about structures. I want to go back and make, like I said, I want to make it a little bit more difficult, right? So we created a structure before called person, and we provided it a name, which is a type string, and we did age of int, right? I'm gonna keep it as just those two, and we're gonna create a person 1, and that's gonna be equal to a person, that entity that struct that we just created before. We're gonna actually create an entity with data, and we're gonna start setting some names, right? And we're gonna make that geo, and we're gonna make the age 18. All right, so what seems to be the issue here? Okay, I guess you have to put a comma no matter what. Save that, and then now we can do one thing. We could do is, look, you're going to a bar, right? You have to be 21 to enter, right? So let's say we got to check your bouncer at the front, and now we got to check everybody's ID. All right, let's check if this person is the proper age. So what we can do is we take person 1, we can take the age, and now we can check if that person age is greater than 21. If it is greater than 21, you may now enter the bar. If not, then we could put you can enter the bar in, and let's make this a format and let the person know how many years they have to wait until they can enter the bar. So let's do that, and then let's do 21 minus the person's age, right? So you know that if it's never going to be like, if it's greater than 21, that would be a problem, because if it ever gets to this else, if the person's age is greater than 21, that would be a problem, because this will be negative. So this is why it's important to have it in this if, because if it is greater than 21 or greater than or equal to, because it's okay if they're exactly 21, they can enter the bar. If they're less than that, say if they're even like 5, if they're 5 and they try to enter the bar, we know that 21 minus 5 is going to be a positive value. So that works just fine. All right, so let's go ahead and clear this out and let's run it. And I always forget to put the new line. So we know the person here is 18, so let's see if they get into the bar. Boom. And I forgot to put years. In 3 years. So let's just do that again. Go run. Boom. So you can enter the bar in 3 years. The person's not old enough. They gotta wait. But say for instance we have person number 2. And there's another person. Open that up, make the name, and it's just my friend Bobby, and he's 22, he's a senior, comes to the bar all the time. And now we can take person 2, the age, move this age right here. Let's check if Bobby's old enough to enter. Let's clear this out, go run. Yeah, he may not enter the bar. Bobby's old enough, but unfortunately Gio's not old enough, right? And let's check also, right, if person 1 is equal to person 2. So if we can do that, if, like I said in the struct tutorial, everybody's different, right? So we shouldn't assume that everybody's the same, but we can also do comparison between structs if that, if you do want to check, right? So if person 1 is equal to person 2, then we can print out we are one and the same. Else you can print out we are different. Clear this out. So now we can see that you may not enter the bar for Bobby, and we can see that we are different because these structs are different. Now, what if we want to do multiple checks, right? I said we can use a multitude of things that we learned throughout this process. So let's try to use some conditional operators, right? Because we also have name, right? We can do a comparison between names. So let's do if the person age is greater than 21 and, right, let's say we can do let's do a check between the names between the two people just to make sure that they're not the same, they're not using the same ID, right? So first I like to put these in parentheses just to make sure that the if statement knows that we're just trying to do this logic right here, and we're trying to do we're trying to group them. We're essentially, this parentheses pretty much groups this comparison or this conditional together. And remember we learned about ands, that means both of these statements that we're about to group has to be true. If it's not true, then it's gonna be false and it's gonna go to this fallback. Because if we were to use or, like we learned, it can be either or can be true. But I want to make sure that both of these have to be true for them to be able to enter the bar. So person1 dot name is not equal to person2 dot name. As long as person1 dot name is not equal to person2 dot name and person2's age is greater than 21, they can enter the bar. They can enter enter the bar because Bobby is definitely not equal to Geo. Now, what if I do, say for instance, have the same name, different age? Let's clear this out. Yeah, you get enter the bar in 3 years. We got caught. Like, right, we have different ages, but for some reason we had the same name and they associate us to be the same somehow. So that is how you can, intertwine conditional operators, some arithmetic into it. Do some comparisons of age. It could be less than, greater than, and, ors. And there is another branch that we can add to this if and else, which is else if, right? It sits between if and else, right? What if we want to, make it a little bit cleaner and check another criteria? We can do that. Else if, open up some braces, and we should be good to go. Now we just have to enter in whatever condition that we want to check. So say for instance we don't want to do this on one line. We can remove this, right? And we can put that here. And now we can have some code run specifically for this case. So let's do fmt println. So say for instance, okay, yeah, this person is greater than 21. Person 2's age is greater than 21. So we can print this out. But say for instance, this is not true, right? We can check another criteria, right? If this is not true, we're gonna check another criteria. If the person's name is not equal to the person's true name, then we're gonna print this out. Now, if both of these are false, then we can finally go to the final fallback. So let's do that. And let's make, in this case, I'm just gonna use person name so I know that this fails. Person one. And then as long as person one dot name is not equal to person two, I change this back to Bobby. Okay. You have a different name. Let me just comment this out. Clear this. Go run. Boom. We have a different name. So yes, this was false, right? Because we set this to 18. So this condition is not going to pass. But we still had another condition we wanted to check, which is true, right? Because Bobby is not equal to Geo. So this is going to be true. We have a different name. It's going to be printed out. It is never even going to get to this else. So we're pretty much stacking conditions on top of each other to check for different criterias. This is powerful. And we're not just restricted to just using one else if. We can use multiple, right? So if you just want to keep stacking conditions, we could. And it will work as expected, right? So if I want to just, I just have this as true because I don't have any other attributes, but actually no, if person one is equal to person two, then we can do fmt println we are one and the same. You can enter. You guys got the same ID. That's not proper. So let me do this. Make this 18. Actually, no. Let me just set person 2 equal to person 1. Right? And let me do clear. Go run. We are one and the same. You cannot enter because person 1 is equal to person 2. If person 1 is equal to person 2, you're the same person. So you can't enter. You're using the same ID. That's not how it works. So this is powerful. If you want to have, stacked conditions to be checked and to have different code to run on those conditions, you can do that. If you want to, check for certain attributes, you can do that. So just take what you learn, play around with this. There's so much you can do with this. And honestly, there's also, cleaner ways of, doing this. We're going to talk about switch statements next, which kind of does this, similar things to this. based on specific criteria, specific cases. So stay tuned for that. But this is if, else if, and else statement branches in Go, and this is how you create them. And you're not restricted to just printing things out. You can do many things within it. It just executes whatever is between these curly braces based on the condition that you set. As long as it's either true, then it's going to run it. But if it's false, then if you have an else statement, it's going to fall back to this else. Now, you're not even forced to use an else. If you don't want to fall back, you don't even have to use the fallback. Only if you need a fallback, you can use the else. But if you just want to have an if statement, then you can use the if statement. But make sure that you have the curly braces. You're not allowed to not have the curly braces. Everything has to have a curly braces for the if and else. So, hope you guys enjoyed. If you have any questions, let me know.